Okay, so let's proceed with our method 2. So using the characteristic root. So from the word itself, gagamit tayo ng roots ng ating polynomial. So yung ating, di ba ang ating differential equation ay in-express natin as d operator or differential operator. Say meron tayong d squared plus 4d plus 3y is equal to 0. So that's derivative of y with respect to x, second, plus 4 derivative of y with respect to x plus 3y is equal to 0. So what we do is we are to take the factors. And then this time, sa reduction of order, di ba ginagawa natin, let this be Q, so on and so forth. So dito, hahanapin natin yung root. So meaning to say, i-equate lang natin to sa 0, so that gives us d plus 3 is equal to 0 and d plus 1 is equal to 0. So we will get d is equal to negative 3 and d is equal to negative 1. So looking at the roots, they are distinct real roots. So magkaiba sila ng root and real numbers. So, if the roots are alpha 1, alpha 2, alpha 3, alpha n, so depende kung ilang order or nth order. So, syempre kung 16th order differential equation, so ibig sabihin meron tayong a sub 16. Then the general solution is y is equal to c1 e to the alpha 1x. So, meaning to say c1 e raised to your first root times x, alpha 2 your second root, alpha 3 your third root, and you have nth root here as the exponent of e multiplied by our independent variable x. So that is given the second order DE, so that's d minus alpha 1 yung factored form natin is equal to 0. Then whose roots pag inequate natin sa 0 tulad ng ginawa natin dito, magkakaroon tayo ng root 1 is alpha 1, root 2 is alpha 2. So all we need to do is to substitute using our presentation dito ng solution. Y is equal to C1 e raised to alpha 1, that's negative 3, plus C2 e to the negative x. So that will be our answer dyan. So, di ba, haba-haba ng ginawa natin dito. So, ang gagawin lang pala natin is you just have to find the root. So, paano natin ito na-derive? So, of course, gamit yung ating reduction of order. So, pakita lang natin. So, this is d minus alpha 2. Y is equal to 0. So, let this be Q. So, letting that be Q, that's d minus alpha 1. Q is equal to 0. So, that's dq dt or dx plus Q multiplied by negative alpha 1 is equal to 0. So, ano ang integrating factor natin? So, that's e raised to negative alpha 1 integral of dx. That's e raised to negative alpha 1 of x. And that integrating factor must be multiplied sa ating original differential equation. So, this gives us derivative of q e to the minus alpha 1 of x equal to, of course, 0 times any is 0. So, integrating both, this cancels out. So, that's q e to the minus alpha 1 of x is equal to c1. Then q is equal to c1 e raised to alpha 1 of x by multiplying this both by e to the positive to cancel this out. So, this will be the solution to our first differential equation dito. But then again, we set q be equal to d minus alpha 2 of y. So substituting, let me just rewrite. Q is equal to c1 e raised to alpha 1 of x. But q is d minus alpha 2. Y is equal to c1 e raised to alpha 1 of x. So this gives us dy dx plus y times negative alpha 2 equals c1 e raised to alpha 1 of x. So what's our integrating factor? That's e raised to negative alpha 2 integral of dx. So that's e raised to negative alpha 2 of x. And that must be multiplied to our original dE. So that's negative alpha 2 of x. So this is derivative of y multiplied by our integrating factor e raised to negative alpha 2 of x equals c1 e raised to negative alpha 1, sorry, it's positive alpha 1x times e raised to negative alpha 2 of x. So you just need to add the two equations, the exponents. So this is derivative of y e to the minus alpha 2x equals c1 e raised to alpha 1 of x minus alpha 2 of x. So integrating the two. So this is, by the way, factoring out alpha 1 minus alpha 2 of x. So integrating the two, pak. So this gives us y e to the minus alpha 2 of x equals c1 e raised to alpha 1 minus alpha 2 of x plus our constant 2. To solve for the value of y, I just need to multiply it by e to the alpha 2 of x to cancel this out. So giving us y is equal to c1 e raised to alpha 1 of x. Kasi pag inad natin ang negative alpha 2x kay alpha 2x cancels out, matitira na lang alpha 1 of x plus our c2 e raised to alpha 2 of x. So this will be our general solution, which is the same as that of here. So again, the number of, or the order of the differential equation determines the number of arbitrary constants. So kung meron tayong 8 order, meron tayo dapat constants 1 hanggang constant 8. So that's method 2 gamit ang distinct linear roots or distinct real roots. So how about complex conjugate yung roots? So if the roots are a plus b, I, then the general solution y is equal to eax c1 cosine x plus c2 sine x. So paano ba natin ito nakuha? So again, meron tayong given, say for example, na d is equal to a plus bi. That's our d1. Ang root number 2 ko ay a minus bi kasi plus minus eh. So plus muna and then minus. So this is d minus a minus bi or d a plus bi equals 0 kasi di ba ito yung pagkuha ng root. So tatranspose lang natin sa left para makuha natin yung mga factors. So minus a minus bi equals 0. So therefore, ang ating differential equation is in the form of b minus a plus bi times d minus a minus bi y is equal to 0. So if I am to let this be equal to q, so we're proving na. So this is d minus a plus bi q is equal to 0. So because we let this be equal to q, so this is dq dx plus q times negative quantity a plus bi is equal to 0. So again, our integrating factor is e raised to integral of a plus bi dx. So your if is e raised to negative quantity a plus bi of x. So multiplying this by our integrating factor. So ang mangyayari, magiging q times ito lang. Punta na tayo sa kabila. So that's q, derivative of q e to the negative quantity a plus bi of x equals. So again, pag minultiply natin yung dE natin by our integrating factor, e raised to negative a plus bix, multiply lang natin yung sa q. And that gives us the derivative of q e to the negative a plus bi of x, which is our integrating factor and our dependent variable. So this is the integrating factor. So of course, equal siya sa 0. So kasi nga, any number multiplied by 0 is 0. So again, so to integrate, so magkakaroon tayo ng q e to the negative a plus bix is equal to constant 1. So q here is equal to c1 e raised to a plus bi of x pag minultiply natin sa positive nito to cancel that out. So again, that's our first solution. But we set q be equal to d minus quantity a minus bi, d minus quantity a minus bi y. So again, d minus a minus bi y is equal to 0. So Q is equal to D minus A minus BI Y. So substituting it there, so D minus quantity A minus BI Y, that's Q, equals C1 E to the A plus BI of X. So that's derivative of Y with respect to X plus Y quantity negative quantity A minus BI equals C1 E raised to A plus BI of X. So again, our integrating factor is E raised to negative A minus BI integral of dx. So that's E to the negative quantity A minus BI of X. So multiplying our dE by our integrating factor gives, so what will happen? So this left side of the equation becomes derivative of the dependent E to the negative quantity A minus BI of X, because that's our integrating factor, equals C1, this times that. So that's E to the A plus BI of X. Pag binultiply, i-add lang natin, so magiging minus quantity A minus BI of X. So let us try to combine this first. So integral and derivative cancels out. So this is, ay hindi pa tayo nag-i-integrate pala. So integrate natin, integral and derivative cancels out. Mali yung na-cancel ko. So this is y e to the negative quantity A minus BI of X. That's BI. Equals C1 e to the AX plus BIX, distributing X here sa inside the parenthesis, and this negative and X here inside the parenthesis. So magiging negative AX plus BIX. But this AX cancels out with that. So magiging Y e to the negative quantity A minus BI of X is equal to C1, put that outside, integral of e to the BIX plus BIX is I times 2BX. That is our integrand now. So this is y e to the minus A minus BIX equals, of course, C I 2BX plus our constant of integration 2. So to solve for the value of y, multiply natin by negative quantity A minus BIX. Of course, I forgot to enclose that there. So be careful dun sa ini-enclose natin, ha? So, yeah, okay. I-ayos natin. Okay, so multiplying it by negative ito, so dapat this should be positive to cancel this out. So, magiging y equals C1 e to the I 2bx multiplied by this. So, this is e to the ax e to the negative bix. So, multiplying this first term by our yung multiplier natin para ma-cancel out ito to solve for the value of y plus C2 e to the a minus bix. So this is y equals C1 e to the ax plus bix, because 2ibx minus bix is simply bix, plus C2 e to the a minus bi of x. Y is equal to C1 e to the x a plus bi plus C2 e a minus bi of x na. But then again, using our algebra, so magkakaroon tayo ng y is equal to C1 e to the ax e to the bix plus C2 e to the ax e to the negative bix. So notice eax and eax are common. So, mangyayari, that's y equals e to the ax as a common factor. Then you have c1 e to the ibx plus c2 e to the negative ibx. So, that will be the remaining term para sa second term. So, using Euler principle, e raised to I theta plus minus is equal to cosine of theta plus minus I sine of theta. So, meaning to say, pag positive, positive. Pag negative, negative yung operation in between. So, therefore, you have y is e to the ax quantity, c1, e to the ibx, that is cosine bx plus I sine bx plus c2, since negative ito, so this is negative I theta, so that's cosine bx, of course, minus I sine bx. So y is equal to e to the ax quantity, c1 cosine bx plus c2 cosine bx plus I sine bx, that's c1 I sine bx, sorry, minus c2 I sine bx. Combining like terms, y e to the ax quantity cosine bx quantity c1 plus c2 plus sine bx, that is c1i minus c2i. But c1i is a constant, c1 plus c2 is a constant, itago natin siya sa pangalang c1 and c2 respectively. Therefore, y is equal to e raised to ax c1 cosine bx plus c2 sine of bx. So that will be our root kapag ka, or ang ating general solution kapag ka ang roots natin ay complex conjugate in the form of a plus minus bi. So, that's case number 2. So, ang case number 3 ay repeated ang roots. So, pagka repeated naman ang roots, of course, pare-parehas lang tayo na A1, A2, A. So, parehas lang din siya ng A3, parehas siya ng A4, so on and so forth. So, suppose A1 is equal to A2 is equal to dot, 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 is equal to a simple A lang. So, general solution, C1 e raised to AX plus C2 x e to the AX plus x squared e to the AX. So, as you can see, pa-increase ng pa-increase yung exponent dito until you have reached n minus 1, depende dun sa aking order of differential equation. So pagka may 7, dapat 6 lang ito. E to the, of course, yung paulit-ulit nating root. So let us try to prove. So suppose I have b minus alpha raised to the second power. So d minus alpha raised to the second power y is equal to 0. So of course, that can be written as d minus alpha y is equal to 0. So of course, the roots are d minus alpha twice. So meron akong d1 equals alpha and d2 equals alpha then. So notice that it is equal. So again, this is q. So that's dq dx plus q times alpha is equal to 0. So ang ating integrating factor is e raised to simply alpha. So this is negative. So that's negative. So magkakaroon tayo ng negative alpha x. So pag minultiply natin siya with our integrating factor, magiging derivative of the dependent and integrating factor negative alpha of x is equal to 0. 0 times our integrating factor e raised to negative alpha x, e raised to negative alpha x is still 0. So integrating q e to the negative alpha x is equal to c1. Then q is c1 e raised to negative alpha of x. But again, q is equal to same d minus alpha y. So that gives us d minus alpha y is equal to c1 e raised to negative lambda x. So that's dy dx plus y negative alpha c1 e raised to negative alpha of x. So at our if is e to the negative alpha x ulit. So this is derivative of dependent y, and the integrating factor e raised to negative alpha x equals. This should be positive. So kasi minultiply natin by ano, so dapat positive ito. Okay, sorry. So this must be positive, this must be positive. So pag minultiply natin siya by our e raised to negative alpha x, e raised to negative alpha x, so that's derivative of y e to the negative alpha x is equal to c1. That cancels out kasi upon multiplying. So this is integral with respect to x, so that's y e to the negative alpha x equals c1x plus c2. To solve for the value of y is c1x e to the alpha x plus c2 e to the alpha x. So, as you can see, kung ilang beses siyang inulit, magdadagdag lang ako ng x. So, kapag ka to the third, so magiging c1x squared e to the alpha x plus c2x e raised to alpha x plus c3 e to the alpha x. So, kung 4, magiging cube. Pag 5, magiging 4, so on and so forth. So, that is characteristic roots or method 2 sa pag-solve ng ating higher order linear differential equations.